Okay, guys, so we're coming back to this activity conversions with grams and moles POGL. And I think some of the confusion was how do we fill stuff in? So this is actually a very detailed guided walkthrough of how to set up the T-chart or the train track, how to do the math, and make things go through. Okay, so you do need to read through this. So it says step 1, prepare your battlefield. You'll set up your T-chart, so we can highlight that. So prepare your battlefield and set up a chart. So this is your chart. Okay. And then this is how you use the chart, right? So it's technically two fractions where you multiply them against each other. So, and when it says multiply here, you're multiplying the bottoms, but you'll still divide across this. So another way to look at that, because we almost never write anything here, that's almost always an invisible 1, is that since we multiply across the top, we would have just this. And so we would multiply, and then if there was a number here, then divide by the bottom. So then divide by the bottom. So you think first multiply across. So multiply across, and then divide top by bottom. So when you put it into your calculator, you would multiply this, technically, and then divide by the bottom. This will come in handy when you're doing multiple step conversions, and if you're putting it all in the same T-chart or train track. Okay, so we're going to go through a couple of these. This is filling in some stuff you already know. So I'm going to actually skip through these because you should be able to do those because that's traditional. This is your roadmap and then everything. So we're going to go through problem 3. We'll go through probably problem 4, and then you'll be able to work on your own. So you have 10 grams of water. Remember, water is H2O. Okay. So water, and you want to know how many moles of it. So you first remember what we've always done is our roadmap. Okay, so what we're given goes first. So we're given grams of water, and we're going to find moles, or MOL, of water. Okay. So this is going to walk us through step by step how we fill in this T-chart. It's going to be very repetitive initially, but it'll work for later, okay, because you'll shorten all the steps and not redraw stuff. So in the first step, we set up our T-chart. So remember, we write our given information in the top left, so 10 grams of water, okay, and then what we want at the end, so this is moles of H2O, and it says do the disco because you swap them. Okay, so grams of H2O go here, and so think the units you want to cancel has to go diagonal, so you're going to drag them diagonal, and so then mole has to go on the top. Okay, so we've got that set up, but what is our conversion factor? The conversion factor comes from molar mass, which you calculate from the periodic table. So then you would answer the check yourself, why does it make sense that we can use the molar mass to convert from grams to moles of a substance? Pause it, why does molar mass, which is in units of grams per mole, make sense that we can use it as a conversion factor in our T-chart or train track above? Pause the video and answer. Okay, hopefully you actually answered that. I am not going to give you the answer. You need to figure that out. So, calculate the molar mass of water. Please show your work. You guys can do that. So, 2 hydrogens plus 1 oxygen. When you multiply and add those together, you should get 18.02. So that means our molar mass of water is 18.02 grams per mole of water. Make sure you are fully labeling your number. So the molar mass is our conversion factor. This is what goes in the second box in our T-chart. So step 3 is to fill in the rest of the T-chart and solve. Okay, so we're going to carry down what we had above. So 10 grams of water. It's a little repetitive because it's walking us through the whole process step by step. H2O. Okay, and now we're going to fill in our molar mass. So this number, 18.02 grams, so the 18.02 goes next to grams because it's always that way, and that's the number of grams for 1 mole of water. So we're going to set up our t-chart. We did that. Now we're going to solve. That means we multiply across and then we'll divide by the bottom. That means that our units here cancel, so we end up with 10 times 1 divided by 18.02. This is letting us see how all the numbers are working out. And when we do that, we end up with 0.55, and then the leftover units are moles of H2O. Make sure you are fully labeling everything. Okay, so notice it's just walking us through step by step on how to fill things in, the entire thought process. It is a little repetitive, but it's to teach you. Okay, so we completed the first one. And now you're going to pause the video and recap the swing or how you drag things down for moles to grams and words. How did you do that? So the swing, remember, was up here. How did you do that? Why did you do that? Pause the video and answer the question. Now we're going to try one more. So say that you have, we're going to skip this one. So make sure you answer the check yourselves. And I'm going to go to number 5 because number 4 is just like the one before it. So I'm going to do this one, number 5. So now we're going to go from moles to grams. So how many grams are in 0.02 moles of beryllium iodide? So this is our given, and this is where we want to go. So I am given moles of beryllium iodide. Okay. And we are going to find grams of beryllium iodide. Okay, so we set up our t-chart, our roadmap. Now we're going to set up our t-chart. So 0.02, I'm going to add a 0 just so we have more than one sig fig mole of beryllium iodide. Okay, doing the disco says I'm going to drag this diagonal. So moles and just the units. And that leaves me with the grams I want on top. Okay, so I've got that set up, but I see grams and moles, so I need to calculate the molar mass. So calculating the molar mass, you'll need to pause the video to do that, but beryllium plus 2 iodines, so beryllium plus 2 iodines, gives us a molar mass of 262.81 grams per mole. Answer the check yourself. Why did you need to do this step? Okay, make sure you do that. What does it help you do? Okay, so now that we have the molar mass, I can fill in my t-chart. So I'm going to copy down what I wrote above. Drag diagonal so that it cancels out eventually. And then put what I want on top. And now I'm going to fill in my molar mass. Grams, so 262.81 grams of beryllium iodide per 1 mole. So notice that the number for grams always goes next to grams, and it's always per 1 mole because that is the mass of 1 mole of that substance. So now multiplying across, right, you end up with 0.02, and I'm going to put that 0 back in, times 262.81. And then the bottom, the units cancel, so I only have a 1 on the bottom. And multiplying those numbers, we end up with 5.3 or just 5. And the leftover units are grams of beryllium iodide. Okay, so this is just a very short, not short, but a very like drawn out process, but to illustrate the thought process that goes into filling in a conversion or train track, doing the conversion for molar mass conversions. So now you have the tools to be able to solve these final 4 problems. Thank you, guys.